Hello guys, today some sum of subarray minimum. So let's get into the problem. Given an array of integer array, find the sum of minimum of b where b ranges over every subarray of array. Since the array may be large, return the answer modulo 10 power 9 plus 7. So the problem states that we will be given an array. So we have to find every subarray. From that subarray, we have to find the minimum and we have to add it. So let's see an example here. So this will be our subarray. So these are the few. This will be our array. These are the few subarrays that are given that can be obtained from this original array. So from this, we have to find the minimum from each subarray, and we have to sum it together. So at this point, pause this video and try to solve this on your own. We will be looking how to solve this, and we will be seeing the logic behind this problem. So let's see the logic behind the problem. So let's take an example like 3124 of an array of n is 4. So the logic behind is like we have to calculate two array has to be calculated. The two array will be the next minimum and previous minimum. So think about which data structure that we can use to find this. So the stack can be used to find the next and previous minimum. So the logic behind stack is like if the top is greater than current, what you will do is you will pop it and put in place of next min. If top is less than current, put in the place of previous min and push the current index. So this two choices will be happen only if stack is not empty. So initially both the next min and previous min will be assigned to the value of n, and previous min will be assigned to the value of -1. So what we are trying to find is that for the index 3, we are trying to find the left boundary and the right boundary of a subarray in which the 3 is minimum. So the left boundary is -1 and the right boundary for the 3 which will be 1. For the 1, the left boundary will be -1, right boundary will be 4. Similarly, for 2, the left boundary will be -1, 1 and 2. No, it will be 1. Right boundary will be 4. So for the 4, similarly, the left boundary will be 3 and right boundary. For the 4, the left boundary will be 3 and right boundary will be 4. So let's solve the example with the algo we have finalized. So we will be having an array, a stack, and we will be having an two array that will be next minimum and previous minimum. So previous minimum will be assigned as -1, which will be a left boundary, and the next minimum will be assigned as a value of n. So here n is equal to 4. So here this is the stack. Since the stack is empty, we will just push the index, which is 0. And for the index 1, what we will do is we will check whether the value of top of the stack is greater than or equal to the current value. Yes, it is true. So we will update the next minimum. We will pop the value of 0 and we will update the next minimum of the index 0, and we will update it as 1, and we will push the value of 1 into the stack. Then for the index 2, the top of the stack is value of top of the stack is 1, but the value is 2, it is increasing. So we will just update the value of previous minimum for the index 2 as 1, and for the value 4 what we will be doing is we will check the top of the stack value is 2, and the value of the current is 4, so which is increasing. We will just update the previous minimum, that is index 2, and we'll update the index in the stack. So stack just contains the index, it does not contains the value. So with the help of the index we can find the number of subarrays in which the current element can be there, can be present. So from this array, how to find the number of subarrays? The logic behind finding the number of subarrays is number of subarray is current minus previous min into next min minus current. So for each index we have to calculate this value, and we have to multiply with the array of I, that is the original value at that particular index. So we have to sum up the array of I into number of subarrays, that this current element act as a minimum, and we have to apply the mod, because the value will be greater than 10 power 9 plus 7, so we have to apply the mod to make it into a correct range. So we have to finally return this value. So let's see how we can code this problem. Thank you. So let's see how the code works. So like I already mentioned in the logic, we will be having a two array which will be previous min and next min, which provides the left and right boundary in which the current element will be the minimum. Okay, then we will have a stack where we can able to find the next and previous minimum. So the first loop, with the help of the logic that I explained, this part, what it do is like it will be used to find the next minimum. It checks whether the top of the value at the top of the stack is greater than the current element. If it is true, it pops the current element and places the value in the next min. And if it is in increasing order, whether the current element value is greater than the top of the stack, what it does is like it just puts the value and it does not pop the element. So we will add the value in the stack. And finally this part is like this part is used to find the number of subarrays that we can get with the current element as a minimum, and we will be multiplying it because we need to sum up the minimum value in a subarray. So we are using this current element, and we are using the k mod is like they mentioned in the question, the answer modulo 10 power 9 plus 7 will be modulo to the current answer to get into the range, and we will finally returning it. So if there is any doubt or something, just comment it. Let me solve the doubt for you guys. Thank you.